A piecewise defined function is one where various pieces are given for different pieces of the domain. So here are two different examples of a piecewise function. So the left graph, that is the graph of a piecewise. And on the right side, okay, this is not related to the graph at all. It's a different function, but that's a function for the piecewise. So you'll notice that the graph has an open circle and a closed circle. So basically, based off of the function that's given, if we look at the one on the right-hand side, if there's no including symbol, we'll have an open circle. If we have something that has an included underneath it, it'll be a closed circle. So here's an example of a piecewise function. So you have the function written out, and you have the graph of the function. So how can we use the function or graph to evaluate at different values of x? So when we want to find f of 0, because 0 is in the parentheses, that means that the x value is 0. So we want to know what's the y value when x is 0. So we can do one of two things. We can look at the graph and figure out where x is 0. So I'm just going to circle it here. So right there is where x is 0. So the y value there is also going to be 0. The other way I can figure this out is I can use my function. So if I look at my domain restrictions over here, I want to match up my x value and figure out which equation this goes with. So if x is 0, the first equation says x is less than -1. So 0 is not less than -1. The second equation, it says that x is greater than or equal to -1 and less than or equal to 2. So 0 fits right in there. 0 is between -1 and 2. So I'm going to use this function, x squared. So I'm going to plug in 0 for x, and 0 squared gives me 0. Okay, so let's look at the next one. So f of -9. So on my graph, I don't have -9 for x. It only goes up to -3. So I could continue to draw this graph and look at the graph, or simply just look at the restrictions. So if x is -9, I'm going to look at my three options. So is -9 less than -1? Yes. So I'm going to use the first one. So I'm going to plug in -9 for x. -9 plus 3 gives me -6. So f of -1. So I'm going to look at that, and if I look at my graph, I have two pieces. I have this piece and I have this piece. Both of them look like they're at -1. However, one of them is an open circle and one of them is a closed circle. So if I want to find when x is equal to -1, I would use the closed circle. Okay, so same thing with the function. -1, if you look at the first one, x is less than -1. Well, -1 is not less than -1, so I'm not going to use this one. -1 would be used in the second one, okay, because it includes the -1. So if I square -1, I get 1. And we can see that from our graph as well. Okay, and then if x is 5, again, I can't see that really on my graph, but if I use the function, I have x is 5, so 5 is not less than -1, so that's wrong. 5 is not between -1 and 2, so that's wrong. But 5 is greater than 2. So I can't plug 5 in since there's no x, so my y is just going to be 3. So we can graph these piecewise functions, and there's a couple of ways that we can graph them. So if you want, you can graph the entire line. So for example, the first equation in our function is 2x plus 4. So if you want to go ahead and graph 2x plus 4, which would have a y-intercept of 4 and a slope of 2, so up 2 over 1, up 2 over 1. Okay, you could draw this line, and then it says if x is less than -3. So where x is -3, anything greater than where x is -3, which is this, is going to be gone. Okay, so that would just continue down. Okay, but it doesn't include -3. So at that point, we're going to have an open circle. Okay, the other way that you can graph this, I'm just going to get rid of this. Instead of graphing the whole line and subtracting, we can just plug in the values that we need. So since x has to be less than -3, the first thing we should plug in is -3. So if I plug in -3 for x, 2 times -3 gives me -6. -6 plus 4 gives me -2. So -3, -2 would be my point. But I'm going to have an open circle because it doesn't include that. So from here, I can either pick other x values that are less than -3 and plug them in, or I can just count my slope. Since my slope is 2, I know that this is going to be going this way. Okay, so here's that piece. Then I want to graph f of x equals 1. So that's just the horizontal line at 1. But we're bounded by -3 and 4. So x has to be greater than or equal to -3. So we're going to start with -3. And that's going to be, an closed circle, since it says it includes it. Okay, so you should have, if you have an open circle, it's fine that a closed circle is at the same x value. So one's going to kind of like pick up where the other one left off. And then we go to 4. So again, when x is 4, since it's just the line y equals 1, and we're going to have an open circle at 4, and it's going to be the line in between them. Okay, because it doesn't include 4. Now in the last one, -x plus 2, again, you could graph this as a full line and then erase, but let's just plug in what we need. So we need x to be greater than or equal to 4. So if we plug 4 in, we get -4 plus 2, which is -2. So at 4, -2, I have a closed circle. And then I have a slope of -1, so I'm going to count that slope down and then draw my line. Okay, so now I have my graph. And then we want to evaluate f of -5. So I can use my graph or I can use my function. Okay, it's usually easier to use the function. So -5, if we plug that in for x, which function should we use? So let's check. -5 is less than -3. Yes, that's true. So we're going to use the first function. And we're going to plug in -5 for x. So 2 times -5 is going to give us -10 plus 4 gives us -6. F is 3. So is 3 less than -3? No. Is 3 between -3 and 4? Yes. So we're going to use this function. So it's just going to be 1. And then for 5, 5 is not less than -3. 5 is not between -3 and 4, but 5 is greater than or equal to 4. So I would use this function, and I'm going to plug 5 in. So I have -5 plus 2, which gives me 3. Okay, if we look at this next one, okay, so it looks tricky. We have an absolute value function, we have a quadratic, and we have a linear. Okay, but same idea. We're going to start with the x values based off of the domain. So if x is less than -1, we're going to start with -1. So if I plug -1 into that, I get -1 plus 3, which is 2. Absolute value of 2 is 2. So at -1, 2, I'm going to have an open circle because it doesn't include it. And then I need values that are less than -1. So for this, since you can't really count a slope, it might be easier just to plug in. So let's plug in -2. So -2 plus 3 is 1. And then absolute value of 1 is 1. And then I plug in -3. -3 plus 3 is 0. Absolute value is 0. I plug in -4. -4 plus 3 is -1. Absolute value is 1. Okay, so as I continue to plug numbers in, this is going to start going up. So an absolute value is like a V. So we're going to go like this. Okay, and that's that piece of the function. For the second one, okay, we're going to start with -1. So we're going to plug -1 in. -1 squared is 1. 1 plus 1 is 2. So -1, 2, I would have a closed circle. So that's the same point as I have as my open circle. But that's okay. I'm just, going to close up that circle. Okay, so the red closing up the circle is part of my other function. So now I want to plug in, 0 is next. So 0 squared is 0 plus 1 is 1. If I plug in a 1, 1 squared plus 1 is 2. And then if I plug 2 in, 2 squared is 4 plus 1 is 5. But I'll have an open circle because it does not include the 2. So this is just that piece of a parabola. And then for the last one, x is greater than or equal to 2. So we're going to plug in 2. So if I plug 2 in for x, that gives me 2/3, because 1/3 times 2, and then minus 5. But I need a common denominator, so I can say this is 15/3. So this was going to give me negative 13/3, which is a little less than negative 4. So I'm going to go to negative 4. Okay, close circle. And then I can just count my slope. So the slope is 1/3. One, two, sorry, 1. Here, up 1. I think there. And that's going to go that way. Okay, so let's just look at a couple more examples. Okay, so x plus 3 if x is less than 4. So you're going to plug 4 in. 4 plus 3 is 7. So at 4, 7, I have an open circle. And then it has a slope of 1. And it's less than 4. So I'm going to the left. So down. Okay, so that's that piece. And then x minus 3 if x is greater than or equal to 4. So if I plug 4 in, 4 minus 3 is 1. So if 4, 1, I have a closed circle. And we want it to be greater than 4, so we're going to the right. We have a slope of 1. So it goes that way. Okay, so we have that. So f of 0, we can figure out what part of the function this goes with. So 0 is less than 4, so we're going to use the first function. So 0 plus 3 is 3. F of 7, so 7 is not less than 4. So 7 is greater than or equal to 4. So 7 minus 3 is 4. And then 4, okay, 4 is not less than 4, but 4 is greater than or equal to 4. So we're going to use the second function. 4 minus 3 is going to give us 1. Okay, and then this last one, negative 7. I need to plug in, so negative 7 times 2 is negative 14, minus 7 is negative 21. So I'm going to run out of space. So I'm going to just go down here. So it's going to be an open circle, and it's going to be going, oops, down that way. That looks bad, but, and then y equals 3 is my next line between negative 7 and 5. So at negative 7, 3, I have a closed circle, that includes that. And then at 5, I'll have an open circle. And this is going to be the line in between. And then if I plug in 5, 5 squared minus 12 is going to give me 13. So at 5, 13, I'll have a closed circle. So let's see here. And then it's a parabola, so I'm just going to do this because I'm running out of space. So if I plug in f of negative 8 is going to match with the first function since negative 8 is less than negative 7. So I plug in 2 times negative 8 minus 7 gives me negative 23. F of 0, so 0 would fit in the middle function since 0 is greater than or equal to negative 7 and less than 5. So that's just going to give me 3. And then f of 7, it'll go in the last one since 7 is greater than or equal to 5. So 7 squared is 49 minus 12 is going to give me 37.